Hello, I'm Ray, the Ray in the Ray Code. In this video, I plan to review the creational design pattern known as Factory. I'll be using C#. I produce and make other videos using other programming languages like C++, Java, PHP, but for this video, I'll be using C#. In this video, I try to cover the whole aspect of this design pattern. I have divided this video into different sections. I have put timestamps in the margin. I start with a list of reasons of why a developer would want to study the design pattern. I show you the UML that the Game of 4 gave in their book of elements to a reusable object-oriented software. I provide a code example. I also post that code at my GitHub site and also at my own website, theraycode.org. I use the .com site of the Ray Code for another project that I'm working on. I'll also perform a SWOT analysis as to why a developer would want to study this design pattern. Now you can find me on Facebook, X, or LinkedIn. Please give this video a like, subscribe, and leave a comment. Also, tell your friends the Ray Code rocks, and maybe repost this video on your own Facebook, X, or link page. And most of all, be awesome. A factory in software design refers to a creational design pattern that provides a centralized mechanism for creating objects. It encapsulates the object creation process, hiding the details of instantiation from the client code. The factory pattern aims to abstract the process of object creation, promoting flexibility, code reusability, and maintenance. C# programmers should study the factory pattern for several reasons. Abstraction of object creation. The factory pattern abstracts the complexities of object creation, allowing client code to focus on using objects rather than creating them. This separation enhances code reusability and maintainability. Centralized control. Factories provide a point of control for creating objects. This can be advantageous when you need to modify the creation process or switch between different implementations without affecting the client code. Code reusability. By encapsulating the creation logic, the factory pattern promotes code reuse. Factories can be used across different parts of an application, reducing redundancy and promoting efficient development. Polymorphism. Factories can return instances of objects derived from common interface or base class. This supports polymorphism, enabling clients to work with objects based on their common interface rather than their concrete types. Flexibility and extensibility. The factory pattern provides a foundation for adding new object types or variations without modifying existing client code. This is particularly useful when dealing with evolving requirements. Encapsulation and information hiding. Factories encapsulate the creation process, hiding implementation details from client code. This enhances the security and robustness of the application. Consistent object creation. Factories ensure objects are created consistently, adhering to predefined rules. This is valuable when maintaining a uniform object creation process throughout the application. Learning design patterns. The factory pattern is one of the fundamental design patterns. Studying it introduced C# programmers to essential design principles like encapsulation, abstraction, and separation of concerns. Collaboration and communication. Learning and applying design patterns like factory fosters better collaboration among developers. It establishes a shared vocabulary and solutions for common design challenges, facilitating communication and teamwork. In summary, C# programmers should study the factory pattern to deepen their understanding of software design concepts and leverage a powerful technique for managing object creation. This knowledge helps creating more modular and maintainable and flexible code, ultimately leading to better software development practices and higher quality applications. UML product defines the interface of objects the factory method creates. Concrete product implements the product interface. Creator declares the factory method which returns an object of type product. We also define a default implementation of the factory method that returns a default concrete product object. Concrete creator overrides the factory method to return an instance of a concrete product. Collaboration. Creator relies on the subclass to define the factory method so it returns an instance of the appropriate concrete product. Hello, I'm Ray of the Ray Code. In this show, I plan to review the design pattern called Factory. I'll be using C#. The factory is a creational design pattern. We begin by adding an interface we call iProduct. The factory encapsulates the object creation process. iProduct will be our abstract product interface. Using the interface will require a use signature method. The use method will be defined by the concrete classes. Let's create the concrete class product A. Concrete product A will be implemented by the iProduct interface, and we get a red squiggly because we need to define the use method. For the use method, we return the message using concrete product A. Now let's create a concrete product B class, and we extend it with the iProduct interface, which gives us a red squiggly because we need to include the use method. So we let the code generator do that for us. Now let's replace the throw error with a return message that says using concrete product B. Now let's create a creator class. The creator class will be our abstract factory class. We make the class abstract, and we give it an abstract factory method. The factory method must be implemented by the concrete creators. So we create our first concrete creator, the concrete creator A, and we extend it with the creator class, which means we need to add the factory method, and we will return a new concrete product A object. Let's now create a concrete creator B class. We have our concrete creator B class structure. We extend the class with the creator interface, which requires us to have a factory method, from which we will return a concrete product B object. So now let's go to program.cs and do our demo in main. We create a factory for product A and one for product B. Let's build and run. We get using concrete product A and using concrete product B. My name is Ray. I hope you have a great day. SWOT analysis of the factory design pattern in C#. S. Strengths. Simplified creation. Simplifies object creation by encapsulating logic within a factory. Scalability. Supports creating various object types without modifying client code. Extensibility. New product types can be added by extending the factory method. W. Weaknesses. Overhead. As boilerplate code for factory classes, especially in small applications. Limited scope. Limited single product family compared to abstract factory. Complex extensions. Extending factories might introduce complexity in multi-layered systems. O. Opportunities. Plug and play. Fits well in systems requiring pluggable components in C#. Dynamic object creation. Enables dynamic object creation based on runtime parameters. Framework. Commonly used in C# frameworks for extending designs. T. Threats. Pattern overload. Overuse can make designs overly abstract and hard to maintain. Alternative solutions. Abstract factory might be preferred for managing object families. Performance. Factory methods can introduce slight runtime delays. That was my video. I plan to create these videos each week. Follow me on Facebook, X, and LinkedIn. Check out theraycode.org and .com. Leave a comment, subscribe, and like. Be good. The Ray Code is awesome.